vector algebra. Then we have linear combination of vectors. Okay, so what does it mean to combine vectors linearly? And then we will look at dots, and your dot product is also called scalar product, and you can call it inner product, any of these three names. So inner product of vectors. Okay, so and then we now have direction cosines. So we look at direction angles and direction cosines before going to cross product. So direction angles and direction cosines. So how do you get the direction angle or cosine of a given vector? And then we will now look at the relationship between direction cosines and dot product. So you are going to see some relationships there. And then after this, we'll go to cross product of vectors. Cross product is also called vector product. So is also called vector product. So why I'm saying all of this is that we could give you two vectors, and instead of saying find a cross product, we can say find the vector product. And then after this, we will now look at equation of lines and planes in R2. Okay, so by the time we introduce the class, you will understand what we mean by R2. Okay, so and then after that, we will now see the other one. Okay, so we'll see the other part is the second part is systems of linear equations. Yes, Rita, you can click on the chart live, and then write your name. Click on the chart live, and then you be live chat, and then you write your name. Okay, so systems of linear equations. Okay, so that's the second part. And under systems of linear equations, we are going to see many things, and after that we will now see the third part, which is matrices. Okay, so these are the three major, not only two. Okay, so it's now clear. All right, Rita, I've seen that. Okay, so matrices and algebra of matrices. Okay, so these are the things we are going to be seeing in this course. So once we are able to cover all of this, then we are good to go. Okay, so let's start with the first one, which is vectors. Okay, so we are going to begin with the definition of a vector. So vectors are not new concepts to you. Many of you have knowledge of what a vector is, even from your year 1 or your secondary school. So we know that in physical discussion, we have two major types of quantities. Okay, so we have what we call the scalar quantities, and then you have what we call the vector quantities. Okay, so if a particular quantity is either scalar or a vector quantity. Okay, so what is a scalar quantity? We said that it is a quantity that has only magnitude. Okay, so this one has only magnitude but no direction, and you can give examples of this, such as mass. Okay, so examples here include mass. Okay, you can talk about speed. Okay, so that's why sometimes when we are talking, we say that speed is not all that matters. You need to have speed and in the right direction. So if a person only has speed, you are just doing, you don't know where you are going. you will discover that you will only be a scalar quantity, and scalar quantities do not really count that much. Okay, so that's an example here. So you can have other examples such as time and the rest of them. We know all of that. Okay, so what about vectors, which is now where our interest is? So what is a vector quantity? From that preliminary knowledge, we know that a vector quantity is a quantity that has both magnitude and direction. Okay, so this one has magnitude and direction. Okay, so and after we've seen the definition of a vector, we will now begin to look at the mathematics of vector. And for us to begin to study the maths of vectors, we will need to give it a mathematical face. We need to give it mathematical representation. And that's why we were told in physics that a vector is a line segment. That's another definition for a vector. It's a line segment that has an arrowhead. So you say it's a line segment with an arrowhead. Okay, so and this particular definition is the same thing as what we have here, because this representation clearly defines the two of them. The line segment represents the magnitude, while the arrowhead represents the direction. Okay, so that means it depicts the same definition you have given here in words. Okay, so that is to say that a vector is a quantity that has magnitude and direction. And that's why, for instance, when we start seeing examples, if we talk about distance and displacement, for instance, if I give you that there is a point here and then there is another point here, and then I say that okay, let me use this example. For instance, all of you are students. Okay, so and let's assume that at the end of first year that a student's CGPA is 3.5. That's the total CGPA. And then and there is another student that also has 3.5. So two students have the same CGPA at the end of their first year. And so let's assume that at the end of second year that this person now has a CGPA of 2.5. Okay, while this other person has a CGPA of 4.5. Okay, so you would discover that both of them, in terms of distance, both of them have covered the same distance. This person moved 1.0, but the only problem is that he moved 1.0 backwards, and that's why the effect is not the same as the effect of this person. This person also moved 1.0. He added 1.0. Why this person also moved 1.0? But because this person moved 1.0 forward, so you can see that the result is different. That's why vectors are very important. Okay, if you remember when we were discussing sets in your year 1 maths 101, we told you something about sets. We said that sets are a set of numbers, you know, where you can have, let's say, 1, 2, 3, for instance. And we said there that the order of arrangement does not matter. That if you write 1, 2, 3, that it is the same thing as 3, 1, 2. That's for sets. When you come to vectors, of course, we are going to be representing vectors dimensionally in this form. If I write a vector 1, 2, 3, you will discover that it is not the same as 3, 1, 2. We are going to see all of this by the time we start. So here, the arrangement is important. The arrangement here represents the direction. So it may not matter for a scalar quantity just as sets, but it matters for a vector quantity like this one. Okay, So now back to our vector representation. So from there we can now begin to see types of vectors. So you can have what we call equal vectors, you can have zero vector, you can have unit vector, and so on and so forth. But before I get to to types of vectors, now what I gave here is what we call the geometrical representation. That's this one. So representing vectors in diagrams. So we call it geometrical representation. And that's why some of you are doing this course, because both of you are geology and geophysics. So you have to do with pictures, you have to do with diagrams. Okay, so when you represent a vector with line segments, that's geometrical representation. Now we have another form of representation which will involve what I did here. So, and that's what we call dimensional representation. Okay, so we can represent vectors dimensionally in this form, or you can call it the condensed form. In this form, we can have something of this nature. Let me say I write this, I draw the coordinate geometry, the plane Cartesian graph. So here is y and here is x. Okay, so you know that this, your line segment, actually can be represented on the Cartesian plane. So it is actually the position of the vector on the Cartesian plane from the origin. So I can draw that particular vector like this. Maybe I should use this. Okay, let me use this my graph to show what I want to show here. Okay, so from here now, we can have something of this nature. There's a reason why I'm trying to make this explanation, because we bring all of this in your exam and then some people find it difficult. Okay, so let's take it that you have something like this. Okay, so and then we are assuming that this point here is, let's say here is 1, here is 2, and and here is 3, and let's assume that this other point, okay, so let's take it that this other point here is 2 and here is 1. Okay, so and here is my vector. Okay, so you clearly see that this vector is at a point, let me call it, here is -2, and then here is +2. Okay, so that means that this vector that I have represented with a line segment can actually be given a dimensional picture. Okay, so what then is dimensional representation of vectors? That's representation of vectors using brackets and entries. So I can write a vector v like this as equal to x, y, z. So here now it means that it has three coordinates. Okay, so it has the x coordinate, the y coordinate, and the z coordinate. So you can also have a vector that will have 2 coordinates, x and y, just like what we have here from the Cartesian plane. And then now these coordinates represent what we call the dimension of the vector. Okay, so that leads us to another important definition. So, but before I get to that definition, we can begin to see some examples of vectors in this form. So you can have a vector, like I said, u can be equal to 1, 3. So you can have another vector v is equal to -4, 0, 5. Okay, in fact, I can have a vector w and it is 3, 1. So, and now you can see what I was saying earlier. Vector u and w are not the same. The x coordinate, and the reason they are not the same is because the x coordinates for u is your 1, while the x coordinate for w is 3. Okay, so once the coordinates are not the same, then they are not equal. Okay, the same for v here. The x coordinate is -4, the y coordinate is 0, and the z coordinate is 5. For this level, we will only measure on two coordinates. On these two, whether two vectors that have two coordinates and vectors that have three coordinates. Okay, and then of course generally you know the vectors that have one coordinate. Okay, so now this is what we are saying. So you can see here now that this vector u and w are not the same. Okay, so this type of representation is what we call dimensional representation. And so you can also write them this way. For instance, this vector u that is 1 and 3. So you can also use the ijk to represent them. So this dimensional representation can also be called the ijk representation. Okay, what do we mean by that? Now your I stands for the x coordinate, while your j stands for the y coordinate, and finally your k stands for the z coordinate. Okay, so the implication is that I can actually write this my u as 1i then plus 3j. Remember that 1i is the same thing as I and then 3j. Okay, so that gave us this. So how did I get plus here? Because this 3 here is positive. Okay, so what that means is that if I have a vector A and is equal to, let's say, minus 2i and let's say plus 5j and maybe minus 8k. So to represent it in the condensed form, that's the bracket form, that's going to give me my I coordinate, which is the x coordinate. You just pick their coefficients, that's all. So if I pick the coefficient of I will have minus 2, 5, then minus 8. So this vector and this other vector are just the same thing. Why am I showing you all these representations? Because when it comes to exam or examples, we can use any of these vectors, any of these representation to ask you questions. So we can give you a vector in a diagram form, that's geometric, like this. We can give you a vector in the bracket form, and we can give you a vector in the ijk form. So you should be able to relate all of them and use it to solve problems. Okay, so we can do more examples here. For instance, if I have, okay, let's take it that I have vector b as equal to, let's say, 4, something like, let's say, minus 1. Okay, so what vector is this in the ijk form? That is going to be vector 4i and then minus 1j. And 1j can be written as j only. Okay, so now note this one also before we move forward. These vectors that we write as in a horizontal form like this, that's minus 2, 5 and minus 8, can also be written in a vertical form. So I can also write this vector this way, minus 2, 5 and minus 8. Okay, so this one now is called a horizontal representation, while this one is a vertical representation. And you can call this a row vector. So a vector can be written in a row wise, and this one is called a column vector. So you can write a vector row wise or column wise. So all of these, they just mean the same thing. So the implication is that this vector A here is the same thing as this vector here, and is the same thing as this vector here. So either of the representations, they mean exactly one and the same. Okay, so this is the introduction of vectors, what vectors are, their representations, and now we are now going into the algebra of vectors. But before we go into algebra of vectors, you can talk about types of vectors. I mentioned, okay, first of all, the definition for dimension. Okay, so what is dimension? Dimension is simply the number of entries or the number of coordinates in a vector. Okay, so the dimension is the number of entries in a given vector. Okay, so here we can now begin to talk about two-dimensional vector. So if I have vector u as equal to -1, 8, so you say that this vector is a two-dimensional vector. And generally we represent Generally we represent two-dimensional vectors as x, y vectors. Okay, that's why you call this one here, you call it xy plane. Okay, you call it the xy plane because that is the two-dimensional Cartesian plane. Okay, so now if we now have two-dimensional vectors, that means they are vectors with two entries. So I can bring in a question and tell you that u is a two-dimensional vector. What that means is that anything that your u will be will only have two entries. So you should note all of these. Those are the things we use in examples or in exams. Okay, so now let's go on. So now vectors that are of two dimensions, they are what we call R2 vectors. So you either call them two-dimensional vectors or you call them R2 vectors. Okay, you call them R2 vectors. So that is where this thing I wrote here is coming from. See it, I told you that by the time we start that it is going to make sense. Yeah, I see some of you giving thumbs up and some emojis. That's good. Please, you can use that to let me know that you are following. Okay, and then if there is any question at any point, you can pause me and ask me the question. You can put it in the chat group here. Okay, so whenever you see R2 means two-dimensional vectors. So I can come in an example and tell you, let U be an element of R2. What does it mean? It means that my U is a two-dimensional vector. That means whatever your U will be will contain only two entries. Okay, away from two-dimensional vectors, we also have three-dimensional vectors. So assume that my V contains X, Y, and Z. So you say that this one is a three-dimensional vectors and they are written this way, R3. Okay, so that means we have R1, R2, R3 vectors, up to Rn vectors. Okay, so this one are called n-dimensional vectors. Okay, so n there stands for the dimension. So assuming that you don't know what the dimension is, you can call it an n-dimensional vector. Okay, so if I say n dimension and the dimension now happens to be 3, that means it is now 3-dimensional. Okay, so take note of that. Okay, so whenever you see Rn means n dimensions. So depending on the n, that will now tell you what type of R it is. It could be R4, it could be R5, but like I said, at this level, we are going to measure at R1, R2, and R3. Now, let me ask, what do you think R1 is going to be? R1 is simply your real numbers. R1 is simply your real numbers. So the meaning is that all real numbers are actually vectors. This thing I said now, you are going to see it in some of our exams. All real numbers are vectors. Okay, so for instance, if I write something like U is equal to maybe 3, this is a vector. And what type of vector is it? It is vector 3i. Okay, so but now it is important that you let me know what particular dimension where this vector is coming from. Let me go to a new page so that you will get what I'm saying. Please follow me now. Now when we start talking about R1, R2, R3 and so on, these ones now are called the vector space. Okay, so or you can just call them the dimensions of the vectors. Okay, now watch this. If I say that U is a member of R1 and that my U is equal to 3, what that means, I hope everybody is here now so that you can get this particular explanation. What that means is that my U can be written as 3i, like I said earlier. What I want to show you now is that U being equal to 3 can mean different things at different points. So watch this. If this same U is inside R2, mind you that U equal to 3 inside R2 is not the same thing as U3 inside R1. So this one now is going to be U equal to 3i plus 0j. Okay, it's going to be 3i plus 0j. So what that means is that your 3 is the x component while your 0 is the y component. Okay, now let me give you this example. Let me see what you can do with it. Let us say that you have a vector 2 2 comma, let me say comma 3, and it is in R3. What is going to be the representation for this vector? If you can write it, if you can hear me, you can write it in the comment section. What do you think will be the representation for this vector? That is in ijk form. So that's going to be vector 2i, of course, plus 3j, and then plus 0k. So that means the third component is missing, and so that means this vector can actually be written as 2, 3, 0. So it's important that you take note of that. Okay, so if you are now given a vector like let's say another, let me take it that this is example 1, so call this example 2. So let's take it that we give you something like maybe 3k for instance, and is inside R3, and we want you to write it in the bracket form. What is it going to be? So this one now is going, the meaning of this is that the I and the j components are missing, and so that's going to be 0, 0, 3. So take note of that. Okay, so now back again into another way that you can see this particular example I'm talking about. Now note that your I and your j and your k represents the what we call the unit vectors. Okay, so in fact let me define the unit vectors now. So unit vectors are vectors that have magnitude 1. We are going to define magnitude later. Okay, so that means if I write my I here, it is the same thing as 1i. Okay, sorry, not like that. So this is the same thing as 1i. The coefficient is 1. Now, if I want you to write this I now in the bracket form, you know the question you will ask me is, from what is the dimension of the vector space where this I is coming from? So for instance, if your I is in R1, then it means that your I is going to just be equal to 1 only. you can put it in brackets, just 1. But if your I is in R2, what is going to be the bracket form? The bracket form is going to be equal to the first component will be 1, but the second component will be 0 because it is in R2 and there is no J here. Your J represents the the second component. Okay, look at another one. So my I in R3 is then going to be what? Is going to be 1, 0, 0, because there is no J and there is no K. Alright, so what if I give you J now in R2? How do you write that? That is going to give us equal to 0, 1, because there is no I, so your I component will be 0 and your J component is 1 because the coefficient here is 1. And so if you are given something like J in R3, what is it going to be? That is going to give you 0, 1, then 0. What does that mean? Your I is 0, your J is 1, and your K is 0. There is no K, there is no I. I hope you are following me. Oh, let it not be that I'm talking to myself. Please respond if you are following me before I continue. Are you following me? You can give something, whether yes, whether emoji, anything. Are you following me? You can use the love emoji to show yes or the laugh, anyone. Please respond though. Let me know that you are following. Let it not be that you just joined and left. You are going to be missing a lot of things. And remember to write your name and your department and your reg number. Are you following me? Okay. Onyinye is saying yes. Okay. All others, where are you? Mavis, Mark Anthony, are you following me? Chidinma says yes. Okay, that's nice. Where is Rita? Rita, have I even seen you here? Okay, are you following me? Onyedikachi Joshua, I'm not seeing your response. Where are all of you? Or you have disappeared? Okay, Joshua have responded. Francis, okay, good. Okay, so if you are following me, kindly respond to this now. Oh my God, I've disappointed biochemistry students, so they told me they would like to join this class. Oh my God, sorry. Okay, now let's go on. Okay, so if you have followed me to this point, write this one for me in the bracket form. Let's take it that you have 2K, and the 2K is from R3. Write it in the bracket form in the comment section. The first two responses I will continue, but I just want to be sure that you are following. Okay, so I can't write my name. Are you serious? Okay. Maybe if you can't write your name, maybe you are supposed to subscribe before writing. And I even see all of you have joined this class without subscribing to the channel. Are you sure you are doing the right thing? That's not the right thing to be done. So go ahead and do that. Okay, so can I see responses? What's 2K going to be in bracket form? Can you write it? 2K that is in R3. If you cannot type, please, you can try to subscribe. Maybe that's the reason why you can't type. But I think everybody is supposed to type. Everybody should be able to type. Okay, yeah, beautiful. 002. I love that. Okay, so this is 002 in R3. Okay, so, and then it is important that you know all of this, because we will begin to give you different examples. You can see something like this. that u is equal to, let's say, 3I minus something like 5k. Okay, even this one is easy to see because of course your j will be missing. So you can have something like this and we tell you it is in R3. So once you have R3, so it means all the three components must be represented. So the u here is supposed to be 3, minus 5, 0. And let me let you know that whenever you are given questions and it's in this IJK form, it's actually more beautiful to put it in this bracket form. Okay, I hope you get that. Okay, so quickly, let's go over to the algebra of vectors. Okay, so under algebra of vectors, we will now begin to define some things. Okay, so we have defined dimension as the first concept, and now everybody knows how to determine the dimension of a vector. So the second thing we want to define is what we call the magnitude of a vector. What is the magnitude of a vector? Rita, I do not know the reason why you cannot type. Maybe, I don't know. I have been following, but I can't put in my name there. Okay, did you create a channel? Okay. Even without creating a channel, you should be able to type any of the two. You should be able to type. Okay. I don't know whether it's from your phone or wherever. Okay, so but just try to, maybe you can go out and come back again and try to see if you will be able to type. Okay, so let's go on. All right, so here now we have the magnitude of vectors. So what is magnitude of vectors? Now, I'm not sure that your course reps are here with the way, okay, if the course reps are here, Zikora and Evans, please do respond. Okay, let's go on. So what is magnitude? If you are given a vector, let's say vector u, now this is how we represent vectors. I'm assuming that u is from R2. So that means you can write it as u1, u2. Okay, so u1 is the first component, while u2 is the second component. If u is from R3, that means it will be u1, u2, u3. Now, if my u is from Rn, so that means it is going to be u1, u2, up to un. So that's what I want to use now. So assume that it is up to un. That means I don't know the dimension. So what that is going to give me, the magnitude of u is written as this. Absolute value of u, or you can write it as norm of u. If you go to our past questions, you will see some of the two of these things in our past questions. So both of them mean the same thing. So this stands for the magnitude of u. And magnitude also has other names. You can either call it magnitude, or you can call it the absolute value, or you can call it norm. Okay, all of them stand for the same thing, absolute value, or you can call it the norm, or you can even call it the distance, or the length. Okay, all of these are, who is this that is calling me? Respect yourself. All of these represents the same thing. So it is either magnitude, oh God of mercy. Right. Sorry about that. Some people are distracting my class. Okay, so it's either we call it magnitude, or we call it absolute value, or we call it your distance. So all of them mean the same thing. So now what is the definition? All right, so the magnitude of u is defined as the square root of the sum of the squares of all the components. Let me write it down. So it's going to be equal to the square root of u1 squared plus u2 squared plus dot 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 up to un squared. Okay, so this is your magnitude. Okay, so by implication, if my u is equal to u1 comma u2, so it means that my magnitude will be u1 squared plus u2 squared. That's all. Okay, so let's go ahead and do examples on that. Okay, example 1. So let us assume that you have a vector v to be equal to, let's say, let me put it in the ijk form. Let's say 3i minus let's say j plus maybe 2k. All right, and you want to find the magnitude, and they ask you to find the magnitude of v. So it's very easy to see. So repeat what you said about the definition. Okay, if you want to write it down, you can actually write it. It's on the board. Okay, let me put it in order, maybe for those of you that want to write it down. Okay, so let me organize it small. Okay, so magnitude, let u be in Rn. So you already know what I mean whenever I say that u is in Rn. That means it is u1, u2, u3 up to un. So the magnitude is defined as the square root of the sum of the squares of its component. For those of you that want to write it, the square root of the sum of the squares of its component. So, but in writing it mathematically, you write it this way: let u be in Rn. Therefore, the magnitude written as this is equal to the square root of u1 squared plus u2 squared plus up to un, depending on the dimension of that vector. If you have gotten what I said here, the person that said I should write it can say that, okay, Rita, you are here finally, welcome. Okay, I can see your response. All right, so let's go back to our examples. Okay, so assuming that we want to find the magnitude of this solution, this is a very important part. So the magnitude of v is equal to the square root of, now this is why I said it is good to put this in the bracket form, so that you will be seeing the components clearly. You will be seeing all the components. So here, if I put my v in bracket form, it's going to be 3 comma minus 1 comma 2. Okay, so immediately I can now see all the components. So that's going to be 3 squared plus minus 1 squared plus 2 squared. Okay, and that is going to be equal to the square root of 3 squared is 9 plus 1 plus 2 squared is 4. And so my final answer will be square root of 14. And of course, there is no perfect square root for 14, so we can leave it that way. Okay, so that's for example 1. Now let's see another example. So assume that you have something like this. Let's take it that u is equal to 2i, and then you have plus 7j, and my v is equal to something like let's say minus I and then plus 3k. Okay, so and you are given a question, excuse me. So assume that you are given a question, evaluate the following. I am going to use this now to cover the concept of addition and subtraction. And so they ask you to evaluate the following. Maybe they say evaluate A, they say magnitude of U. B, they say magnitude of V squared. And then C, they say magnitude of U plus V. And then D, they say maybe magnitude of V minus U. Okay, so let's assume that this is what you are given. Okay, so these are the kind of examples or questions you should expect even in exam. All right, so we will not just come and ask you to find only magnitude of U. It does not make sense. We will try to add one or two to it. Very confusing. Sir, this is confusing. Which one? Okay, which one? Is it the magnitude? God's will. Sorry, it's not God's will that said. God's will just said, It's not good to just say, Say what is your problem. Alright? It's Pascal that says it's confusing, and then Helen echoed it. Okay, which one is confusing? Respond to me so that I can clear that. Is it the magnitude? Is it the magnitude? Or is the person that typed it no longer here? Zikora, see when you are joining the class. Please respond to... Nobody is talking. Okay, so let me use this example to explain it further. Okay, so let's begin with example 1. Oh, sorry, A now. So your U is equal to 2I plus 7J. And you are asked to find the magnitude of U. Okay, now, for you to get the magnitude of U, okay, sir, is the absolute value the same thing as the double line? Yes, that's what I'm saying. The absolute value the magnitude can be written like this or like this. The two of them mean the same thing. It's just representation. The person that asked this question is, the name I'm seeing on your YouTube is K Chris. Somebody can call you K and another person can call you Chris. You will answer to the both of them because both of them are your name. Okay, so that's the same thing. It's just representation. And the reason I'm showing you is that you can come in exam. We will use the one of single line or the one of double line. You will now say, oh, Surprise showed us only the single line. We don't know which one is double line. That's why I'm showing you now. The double line or single line is the same thing, but although they have different names, the single line is called absolute value, while the double line is called norm. So you either call this one is called norm, this one is called absolute value, but under this concept they mean the same thing, magnitude. So you can either write magnitude of U like this, or you write it with the double line. Is it okay now? Okay, so let's now go ahead to solve it. So how do you find the magnitude? Helen, I've seen what you said. That's why with this example, you should be able to understand it now. So the magnitude of U is the square root of, you just pick the components and square them and then add. So if you pick the component, the first component, if you write it in bracket form, the first component is the coefficient of I. What is the coefficient? Shebi, we were the ones writing all the things I gave here. 2k, you wrote it as 002. So you should be able to put any vector in the bracket form. If you put this one in bracket form, that's going to be 2, 7. Okay? So all you need to do is to pick this component, square it, plus you pick the second component, square it. If it is up to 3, you pick the third one. If it's up to 4, you pick the fourth one. If it's up to 5, you pick the fifth one. Does it make sense now? So all you will do is you keep picking the component. Once you pick, you square and add. Pick, you square and add, and so on and so forth. And after that, you just find the answer. So what is the square of 4? Sorry, the square of 2 is 4, and the square of 7 is 49. And so finally, my answer will now be the square root of 53. Please, let me get some reactions. Have you understood it now? Is it clear? If it is clear, can you say yes, it's clear? Say yes, it's clear. Let me be sure that you are following me. Is it clear now? Yes, you can give emojis, whatever. Okay, so if it is clear now, so let's get the magnitude of V together, everybody. What is the magnitude of V? Everybody do it and write the answer. All right, I'm seeing the emoji, but I would also like response, especially from Helen and from Pascal. Okay. Yeah, Rita says right on. I like that. Onyi says it's clear. Okay, so everybody get for me the magnitude of V. Look at the V here. The magnitude of V. Yeah, the magnitude of V. Yeah, Chidima says right on. Yeah, Joy, Kosi. That's nice. That's nice. Rejoice. Okay. So get the magnitude of V, everybody. What's the magnitude of V? Write your answer on this thing. Okay, magnitude of V, our V is minus I plus 3k. V is minus I plus 3k. Can I see response? Even if it is one response. Okay, while I'm waiting for your response, let's continue together. So that's going to be, so it will also be good that you write out your V in the bracket form. And so our V in bracket form is going to be minus 1, comma 0. Don't forget that it is 3 dimension. So the J is going to be 0. So comma 0, comma 3. Okay, so that means the magnitude is going to be the square root of minus 1 squared plus 0 squared. But of course, you do not have to bother yourself writing this 0 squared, because 0 squared is still 0. And then plus 3 squared. Okay, so that beautiful, beautiful. Oni, yeah, rejoice, yes. Okay, Helen says clear. Thank you, sir. Chidima, you are writing only 10. Okay, you are giving me the answer for B, which is square of the magnitude. Thank you. But I said we should get the magnitude first, so it should be root 10. Beautiful, beautiful. Chidera Joyce, Chidera Rita, I can see all the responses. That's correct. So the square of minus 1 is 1, and then you have 0, then you have 9. So this is going to give you the square root of 10. All right, so that now means that the answer for our number B, which is the square of the magnitude of V, is now going to be the square of root 10. And by the time you take the square of root 10, square will cancel square root, and that will give you 10. And I want to believe that that's how Chidinma got 10 initially. Okay, so that is the solution. That is the solution for that. Okay, so for example C, please, for you to get example C now, you need to add your U and your V. I'm going to attach 0 here. All right. Oh, somebody was calling me. Nobody should be calling me anyhow. Mind yourself. Okay, sorry about that interruption. Okay, so now in addition of vectors, you are going to be adding component wise. Follow me. So if I have something like this, the I component will add to I component, the j component will add to j component, and the k component will add to k. So here I'm going to have 2 plus minus 1. Of course, you know 2 plus minus 1 is the same thing as 2 minus 1, and that is 1. And then comma 7 plus 0 is 7, comma 0 plus 3 is going to give you 3. And so our u plus v is equal to 173. So this person that asked this question here, that asked you to get the magnitude of u plus v, wanted you to first of all get the value of u plus v, and then you will now look for the magnitude, which will be the square root of all of that. So I want you to get the magnitude now, and then use the same method I used in doing the addition to do this subtraction and also get the magnitude that we want to do now. Okay, and I've also shown you how to do addition of vectors now, but I also want you to see how to add vectors when they are in diagrammatic form. Okay, so for instance, you know I told you that vectors, okay, remember we did not do this last one together. Maybe we should do it. Our u minus v will be equal to 270 minus 103. And so if you subtract 2 minus 1 will give us 3. 7 minus 0 is 7. 0 minus 3 is minus 3. So the magnitude will be equal to the square root of 3 squared plus 7 squared plus minus 3 squared. And that's going to give us 9 plus 49 plus 9 again. And that will be equal to, this will be 68, of course, you are correct. That's 58, that's 67. Okay, so that's beautiful. Sir, please, can you solve one more example for us? Okay, no problem. Let me bring one more example for you. Okay, let's see something like this. Let me bring this one from here. Suppose okay. I need something that will be beautiful. Okay, let's use this one. Okay, so let's use this one. Let me go to a new page. That will be example 3 or so. Okay, so let's assume that you have, okay, let u be equal to 12. Okay, it's good to always put it in ijk so that you will be the one to bring it out. So 3j minus 5k, and v is equal to 2i minus 3j plus 3k. In this early January that people are fighting is well. Juliet, please don't come late in another class before I'll break your head though. Okay, so here we are now asked to find, okay, let's say a. Okay, let's try to do what should we do now? What should we do? Okay, let's go on. Let's do magnitude. Okay, let's start with magnitude of u. Okay, magnitude of v. Those of you who are already here, you can start doing it and writing the answer for us. And then c, let's also bring in addition of u and v. And d, you can also bring in subtraction. I am doing all of this so that it can allow you to practice more. Okay, so that's why I'm adding all this. In fact, you can even add square if you want. Okay, so solution. So Juliet, here we now have that the magnitude of u is going to be equal to okay, Francisca said root 67 for D. That's correct. Okay. So here it is going to be now, but with time, as you progress in your learning, you may not need to put this in the bracket form. You will already be seeing the components. So like here, the first component is 12. So 12 squared plus 3 squared plus minus 5 squared. Okay, and that is going to be equal to, so here we now have square root of 12 squared is 144 plus 9 plus 25, and that is going to give us this one will be 34 plus this will be square root of 178, if I am correct. Okay, Rejoice already gave us an answer. That's beautiful. That's for number 1. So Juliet, with this example I did now, I think it makes more sense. If it did, can you do the second one together with everybody and let me see your own solution? Quickly. And from there we now begin to go to other things. Okay. I'm waiting for example B. That's 3B. Like I said, Juliet, I would like you to, okay, Sylvia, okay, Rejoice has done B. Okay, Juliet, let me see your response for B. Is you I'm waiting for. Juliet, you're from which department? Where did you write your name? Let me check. Which department is that? Okay. I'm not seeing it. Okay. Raul Chukwu Ronald. Okay. That's for B. Okay. Alright. Juliet, I want to believe that you have gotten it. And root 22 should be correct. So this is going to give us magnitude of V, which is okay, yeah, only. Okay, this is 2 squared, which is 4, plus minus 3 squared, 9, plus 3 squared, 9 again. So that is square root of 22. That's correct. Okay, so let's progress now. So I want us to see addition of vectors under geometry. Addition of vectors when they are in geometric form. That's in diagram form. Okay, so how do you add vectors when they are in diagram form? Okay, so it is also very, very important because we most times bring that a lot of times in exam. Okay, see this. Assume that this is a vector and let me call this vector U. Some of you will say, sir, you are using U and V a lot. Yes, that's when it comes to algebra and maths, we use X and Y a lot. But when it comes to vectors, we use U and V a lot, and then sometimes A and B and W also. Okay, so that's not a problem. Okay, oh, somebody is already doing C. That's exactly how this thing works. And I'm going to be helping you further. In that group that we created, I will be dropping some past questions so that some of you can use it to practice. The more you practice, the more it becomes better with you. One thing about me when it comes to teaching, some of you that have been under my teaching, is that I teach in such a way that I want my students to get the best. The truth is that if I teach you the way I teach and I see your result and you get B, and I feel that you should get A, I feel, worse than you. I actually feel pained than you would feel. Some of you don't know that, but that's the truth about me. Okay, so I'm going to be providing you with past questions and all of that. All you will need to do is to pay attention. Follow, like we created this class now. You join. We are just about 33 here now. and in that group we have over 120 something. That was what I talked about when I posted the first comment, that all I needed is your cooperation, because if there is no cooperation, there is no point. I will just leave it. Anything that happens, it will happen. But let's go on. So under addition in geometry, look at how the principle, how it works. So let's take it that this is my u, and another vector starts from where you stopped and then stops anywhere. Let's call it v. Now the addition of these two vectors is simply the vector that will start from where you started and stop where v stopped. So something like this. Don't mind the diagram, it's not allowed. Anyway, I can use my straight line. Let me use my straight line so that it will be straight. Since he's insulting me, he does not know that I have line to use. Okay, so now, so this means that my u plus v is just this line. Okay, that is my u plus v. And so the question now is, where does questions arise on this? It's very easy. We have a lot of questions that can arise here. Let me try to bring one. Okay, let me see if I can get just one question. Oh, just a moment. I've already seen one, but there is one I want you to see. Okay, look at this example here. Okay, here we are told that okay, example, let me call it example 1. Okay, so we are given something like this, and here is called w, and then this place is called u, and then this one joined like this. Let me use this to join it. This one joined this way. Okay, so something like this. Okay, and the question says write w in terms of u and v. Okay, in terms of u and v from the diagram above. And somebody will be saying, can this be asked in OBJ exam? Yes, it can be asked in CBT, because the answer is just a line. So we can just draw something like this and ask you this question. So the question now is, how do you get the solution to this problem? So it's very simple, and this is going to be leading us to something else that is very important. Maybe that's what I'll use to end this class. Okay, so now, okay, sorry, this one is v. All right, so what is going to be the solution here? First of all, watch from what I explained here. You can clearly see that, let me start from u. You will see that u started from here and ended here, and then w continued and ended, and your v started from where you started from and ended where w ended. So the meaning is that your v is the sum of u and w. So if that is true, you are done. So they just said you should write w in terms. In terms means you should make w the subject. So my w is equal to v minus u, if you take u to this side, and this is your answer. I don't know if you understood what I said there. Okay, so I can see some of the responses. Chisom had to put this one in a reduced sort form. That's okay. Okay, Kelvin and Rinze, you just joined. Okay, C, I'm seeing 10 root 2. That's root 200. That's correct. I'm seeing D, root 104. Okay, I'm seeing all of that. Okay, that's correct. Okay, so did you follow me in this example I gave here? So how to write W in terms of V and U? If you understood it, let me try to see if I can create another one myself. So assume that you have something like this now. Something like this. Okay. Actually, it's not only three lines alone. It can actually be more than 3 lines. In fact, let me introduce that here. So let's take it that is something of this nature. Okay. So watch this. So assume that you have something like this. Okay. And let's take that this one continued like this. Let me use white to do the arrow. And let's assume that this other one goes this way, and that this one goes this way, and that this one goes this way. Remember that this one went like this. Okay, so let's take it that this one is A, and this one is B, and this one is C, and this one is D, and this is E. Now pay attention now. I want to say something here now before we do this example. Now, what is it? I should have said it when we started. If you have a line segment like this that is a vector, and this is U, the one that is in opposite direction, that is the same size, is equal to minus U. So what it means is that if a vector U is equal to, let's say the direction of this vector is like this, is equal to 3. If you turn it the other way around, the one in opposite direction will still have the same magnitude, but the only thing is that it will be negative. So look at what that means, is that if I have a line, you know we can represent vectors with alphabets AB. So if this vector is AB, vector AB, that means it's going this direction from A to B. That's vector AB. That's actually where I wanted to stop, but this explanation has made me write it now. Okay, so somebody said I should explain the last example. Let me come back to it. Okay, in coming back to it, let me write it here. Okay, what we are saying is that if we have 2 vectors or 3 vectors like this, in fact, let me use 3 vectors to explain it, or more vectors. Let's assume that we have something like this. This one is 4. Okay, so if this one is going in this direction, this one is in this direction, this one is in this direction, and this one is going like this. Watch what I am saying. That let's take it that this is U, V, W, and here is A. You can see that U started the journey. So U moved to this point, and V continued in the same direction, and W continued in the same direction. Now, but A did not continue the direction. A now started from where U started and ended where U ended. So what this means is that A is simply equal to the sum of U, V, and W. So the vector that starts from where this one started from and ended where this one ended, so far as all of them maintain the same direction, will be their sum. So if I have something like this, this one went this way, this one went this way. Let's take it that this is A and this is B. So look at this. So this one started from where A started and ended where B ended. So if this is C, so my C is equal to A plus B. Did you get that now? If you have gotten it up to that point, let me now give a simpler example. So assume that you have something like this. So if this one is A and this one continued as B, and let's take it that this one continued, or let me go this way. Okay, let's take it that this one is A, but this one went this way, this one went this way, and this went this way. So let's take it that this is X, Y, and Z. Can you create a relationship between the four of them? Let me see what you have. Create a relationship between these four. Okay, so I'm seeing some thumbs up. That means it's making sense. So help me get that. Let me get that solution. Sorry, help me. What is create a relationship? The way I created for these two, depending on what I have in the diagram, what do you think will be the relationship between these four? Oh, this is beautiful. This is beautiful. Yeah, Zikora, Chidi, K. Chris. Yeah. Chidima, you are using comma. Is it comma or plus? There's no plus in your phone. Beautiful, beautiful. You have gotten what I meant. Okay, now that's nice. So let's go back to what I was explaining earlier. Okay, now we are saying that if this is AB, now listen to the movement A to B. That means the direction is this way. Now, if you talk about BA, BA is not equal to AB. Under scalar, they are going to be equal because the distance is just the same. AB is the same as BA in distance. But in vector, if you are going in opposite direction, they are not the same. So what is now the equality there? So your AB is just going to be minus BA. So the opposite direction will just be the negative. So that's exactly what we are saying. So the meaning is that if I give you something like this, look at this. Let's take it that here is A and that here is B. Let me say B. And here is C. You can clearly see that all of them are continuing in the same direction. So it will be difficult to write a relation here. Can you write? Let me see. What do you think? Can you write a relationship here? No. From what I explained, you will see that there will be no relationship. All of them continued in the same direction. Nobody closed it. If you watch here, this person closed the movement. This person continued, and this person now closed it by starting from the continuing point to the end. In this one, A continued, B continued, C said no, let me close it. Like last born, it started from the beginning and ended where they ended. In this fourth one, Z started it, Y continued, X continued, and A said no, let me start and end. Okay, but if you look at this example I gave here, let's say you use A started it, B continued, and C still continued. So is it possible to write a relationship here? If you follow what I have taught you here, you see that you cannot write any relationship here, but you can actually write it using what I've shown you here. So what should you do? You can use any of them and turn the direction so that it can close it. So I can use my C. If I use C now and change the direction, that means I will turn the direction this way. But when you now turn the direction, what you will have here will no longer be C. It will now be minus C. Please give me a response if you understood what I explained now. If you understood what I explained now, you can give any reaction, any emoji, or you can say yes, I understand, or something like that. And so from here now, I can create a relationship now. And what is the relation? Thank you, Zikora. And what is the relationship now? C has now closed it. So my minus C now will be equal to A plus B. Oh, I love this. Did you get it? Did you get it? Did you get it? Yes, 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 yes. I love that. So be giving me the response so that I will know that you are following. Okay, and so finally, to this big example here, let's now see what this example is going to be. Okay, so what is it going to be? You can start with anyone. We can start. Oh, good, Helen, good. Okay, Rukewe, good. Rukewe, you'll be shocked how I got your name. I got the pronunciation because I've met somebody that bears the name. Okay, so all right. So let's go to this example here. Let's try to create a relationship here. We can start with A. If we start with A started the journey, B continued in the direction, C continued in the direction, D refused to continue. So what do? We can choose to change the direction of D. If we change the direction of D without changing it, if you change the direction of D, nobody asks you to change it. So when you change it, you come and balance it by making the D to be negative. And immediately you have balanced the whole diagram and you can now create a relationship. And so you can see A started the journey, B continued, C continued, D continued, minus D continued, and E now ended the journey. It started from the beginning and ended where they ended. Therefore, my E is equal to A plus B plus C plus minus D, which is minus D. And that is the relationship here. So that is to show that the order close the journey is also negative. Yes, that's exactly how this is going to be. And that's actually what happened here. So you can actually say that W closed this on a negative direction. You can turn it around and it will close, it will become negative. Watch what I am saying. Okay, no, I will use U, not W, because we used U here. So we got W to be V minus U. Okay, so we can actually use U here. So here now we can turn the direction of our U. If we turn the direction of U, is going to now go this way. And so U will now be minus. So you can see that W started and ended. Therefore, our W will be equal to our minus U plus V, which is the same thing as V minus U. And that is what we got here. So I hope it makes sense. All right. Now, let's now go back to finalize what we did with A and B. And that's where the second part where we used to bring questions from here. Remember I told you that we can give you a diagram and ask you to give a relationship. Now, what other thing can we ask you from this geometric part? Look at this. Remember I said that we can represent lines with alphabet. So I can write here like this. I can write here as B and write here as C. So I can tell you what is AB plus BC. So you can clearly see that AB is this direction and BC is this direction. So that means my AB started it, BC continued. So the answer of their sum is going to start from A and end at C. And that is this one. So AB plus BC is simply AC. And if you understood what I just said now, I'm going to use it to give you a general condition, or what should I say, definition for addition of vectors of this form. So if you have something like AB plus BC plus CD, now watch it. So far as what ended this, the alphabet that ended this one started the next one. and the alphabet that ended the second one started the third one, your answer is the first alphabet and the last alphabet. That's AD. Did you get this I just said now? Did you get it? Now what this I am explaining now is doing for you is that you don't need to draw the diagram again. All you need is just put alphabets on them. Like this one now, I can choose to put alphabets here. If I do it like this, I can just remove this and then remove this. So what I'm going to have here now, A, B, and C. So you can see that here now, AC started. So you have AC and then plus CB. So your answer will simply be my B. Now it's going to be AB. And what is your AB? Your AB is this direction, which is exactly what we had before. C, A, and B. And that's what I said to show you here. So this one comes most of the times in our exam. So if you followed me to this point, what is the value for this? XY plus YZ plus ZA plus A, what should I use here? AB. What's the answer for this? Response. Okay, so let me see your response for that. XB, Zikora, that's beautiful. XB, Frances, that's beautiful. XB, Onyinye. So you are following. That's nice. Now, I now want to, okay, let me call this example 1 here, example 2 here, example 3. Now, let me try to shake you small. Okay? Let me try to shake you small. Beautiful. Namesake. That's good. Michael, Chidi, Legendary, Chidima, Joshua. Okay, let me try to shake you small. What if I give you something like AB plus let's say something like okay, let me go plus BC then minus DC. What is the answer for this? That's going to be where we will end this class. If you get this one now, I will give you people the thumbs up for the end of the class. Thumbs up for the end of the class. Thumbs up for the end of the class. Rejoice, you're a thief. You're a thief. You're a thief. Yeah. Weke Precious, namesake Chidi, okay. Legendary, okay. Legendary says, Legendary, you have not finished it. Try to finish it. But I love what you did there. That's very beautiful. And that's actually how we are going to do it. But you can use other ways. Ken Presh, okay. I'm seeing minus AD. Are you sure? Chisom. Chidi, are you sure? Minus AD. I'm seeing minus AC. Okay, that's very beautiful. I love the fact that you are all responding. Chide, Rita say I should come again. With which one? If I punch you. Okay. So if it is here that you said I should come again, let me repeat. Okay, so watch what I said here. If we have AB and BC, so what it means that a vector started from A and went in the direction of B, and another vector continued from B and went to C. So the answer will be from A to where it ended, which is C. That's how we got AC. So we just said that all you need to do is watch out for the pattern. Once it starts from X and end with Y, and the next one starts with Y, end with Z, so your answer will be the first and the last letter, which is XZ. So Chidera, Rita, that's just the pattern. Okay, look at this one. It started with X, ended with Z. The next one started with the same Y, ended with Z. The next one started with the same Z, ended with A. The pattern is maintained. So just pick the first and the last letter. That's your answer. Okay, finally, let's now come to the exercise I gave here. Now, first of all, let me announce that many of you got it. Rejoice is laughing. Yes, Rejoice got, I think she was the first person that got the answer. The answer is AD. And how is it AD? Okay, so let's look at it. Very simple. Here I have AB, and then the second one started with BC. But the third one did not start it. So the third one is now DC. But I am lucky enough that the second one ended with C. But instead of this one to start with C, it ended with C. So what should I do? I will turn it. So if I turn it, see what I'm going to have. AB plus, okay, let's do it the way Legendary did his own. So Legendary first of all added these two. So by the time you add these two, you are going to get AC. Because you can see that this one maintained the pattern. So you can pick the first and the last. And that will give you AC. So you now have minus DC, which was what he gave to us. And that's also what Diamond gave. Who else gave that? That's Legendary me gave that. And that's what Diamond gave. Who else gave that? Okay, but you don't stop here. What should you do? You will turn this DC. And remember we said that if you have AB, that it is the same thing as minus BA. So you can turn it, but the only thing is that if you turn it, it will become negative. So if I turn my DC, it will become minus CD. Are you getting the point now? And so I have gotten what I needed. So minus times minus is plus. So you now have plus CD. And this has maintained the pattern now. And your answer is AD. If you got what I explained now, let me see your reactions. And of course, that would be the end of